One of the common atomization techniques that's used especially with atomic absorption spectroscopy is a flame atomizer. So in this video we're going to look at the flame atomizer and sketch it out and kind of walk through what each part is doing. Now, I am not an artist, I don't pretend to be, but this kind of bare bones sketch of a flame atomizer should get us through the major concepts of flame atomization. All right, so in a flame atomization or flame atomizer, so in this process there's a couple of parts that we're definitely going to need. So we're ultimately going to need somewhere for the flame to come out, and this is called the burner head, and is where our flame is going to come out. So you've got kind of a big flame coming here. Okay, and so there's my flame coming up, and to build this flame we need a certain number of things. We're going to need to feed our sample into the flame, we're going to need to feed a oxidant into the flame, and we're going to need some kind of a fuel as well. So we need fuel, oxidant, and sample all feeding up to make this flame that's going to ultimately be atomizing the sample as it's fed into the flame. So how do we make this happen? Okay, so we're going to use kind of a cylinder here, at least I'm going to draw it as a cylinder. Draw a cylinder here. All right, so here's my cylinder. All right, going into the center of the cylinder, we need somehow to get our sample in, okay? And so I'm going to feed my liquid sample in. Okay, and so here goes my sample fed in to the flame atomizer. But if this is just a regular old plain old liquid, all it's going to do is form droplets at the end of this that's going to drop down to the bottom, and that's not going to be very helpful to get it up and into the flame. To get it up and into the flame, what we really want it to be is in very, very fine droplets. We want it aerosolized essentially into the gas phase in some way that it's going to stay in the gas phase long enough to be propelled up into our flame. So let's talk about how we do that. So to do aerosol formation, we're going to need to do a technique called nebulization. And if you've ever been with someone that's getting any kind of a breathing treatment where they've got a liquid solution and it's going to get vaporized in a way that they can breathe it in, you'll know that it comes with an air compressor, and it's basically pushing compressed air through the liquid in order to get it into some kind of a vapor. And that's essentially what we're going to do here. So feeding into this liquid sample and right around this and feeding through it is we're actually going to go ahead and feed some gas into this line with the sample. And here we're going to feed our oxidant. Okay, and this is in the gas phase. So it's commingling or intermingling with our liquid sample, and as it's intermingling with it, it's going to start breaking it up into into small little droplets, such that when our liquid comes out of this tube into our little container here, we now have these little tiny droplets. And that's what we want. And they're in this gas stream that's flowing from our oxidant here. We're getting a gas flow into the chamber here. So we've already taken care of the oxidant, which is one of the things that we needed for the flame, right? We needed an oxidant, and we're going to need some kind of fuel to make this work and to end up with our sample in the flame. Okay, so we've got our sample coming up into the flame. We've taken care of the oxidant. Now what about our fuel? Well, we want it to get really mixed with the oxidant before we hit the flame. We don't want the oxidant to not mix with the fuel. Then we get areas of high oxidant versus areas of low oxidants and high fuel. And we really want it to be a nice homogeneous mixture. So we want to put the fuel in also on as far from the flame as possible so that it has plenty of time to start mixing before we get up to the flame. So I'm just going to put another tube in to my container here, and we're going to feed the fuel in, also as some kind of gas phase. Now when I say gas, I'm not talking gasoline, I'm just talking the gas phase. Okay. So now we have our sample in, we've got all of that, but a couple of things to think about here is we want to really promote mixing, and we don't want any really large droplets to end up into the flame, because then it's going to take too much time to evaporate those large droplets and atomize, and by then it might have actually been swept out of the flame and we'll never get the measurement. So we want really fine droplets to enter into the flame, and we want everything to be really well mixed. So what we're going to do is we're going to add what's called baffles, and this is basically like a little disc fan here, okay? And what this baffle does is it enhances mixing. Okay, so we've got it promoting mixing here. But we still know that there's likely to be some large droplets in here, and we want to really kind of make sure that it doesn't get that far to kind of make the baffle work so hard. So what we actually do is we put what's called a glass bead, just this little bead here, suspended. And the purpose of the glass bead is to break up large droplets. Large droplets hit it, and they're going to be broken into smaller droplets as they hit the bead. So before they even hit the baffle, we're starting to break them up with this glass bead. Now, some large droplets never even make it all the way to the glass bead. Some larger droplets, gravity takes a hold and they just fall down, right? They're on a trajectory that they just fall to the bottom. And we don't want a ton of liquid to build up in the bottom here. That's going to really limit our efficiency. So we're going to put a little drain in the bottom. And if you run a flame atomizer, what you'll notice is a lot of sample ends up in the waste. This ends up being a very inefficient process, and a large percentage of your sample actually will drain to waste rather than getting up into the flame where we want it at the end. Okay, so some of our sample ends up in waste, some of it ends up in the flame, but a lot of it ends up in waste. All right, so this is the basics of our flame atomizer, and I have a note to say this is only about 5% actually makes it to the flame, so 95% ends up in waste, and that's where a lot of our sample ends up. Okay, we get about 5% of our sample makes it to the flame. All right, so here's our flame atomizer and the basics of how it works. We have a liquid sample. It's going to be nebulized into our sample chamber using an oxidant, some kind of a gas here that's going to help with our flame formation. This is mixed with another gas that's serving as the fuel. And in this mixing, we're hoping to break up the large droplets into smaller droplets using the glass bead and the baffle to really promote mixing. Any large droplets that don't make it up to the flame are going to fall out to waste, and that's about 95% of our sample. And we get flame and oxidant and small droplets of our sample heading up into our burner head, which is where the flame comes out of. And there you have it. There's a flame atomizer.